Hello and welcome to this new tutorial. In this tutorial we will see how can we perform pose estimation using OpenPose library. I will show you how we can use it for single person pose detection, which we can later extend it for showing multiple poses in the same image or in the video. So if we are given an image like this, we would like to apply the pose estimation and get the key points for that pose and draw them on this image. So let's see how we can do this. Let us first understand the basics of the open pose, how we can process its output, and then we will start implementing it. In the Google, we can search for open pose and we can go to CMU Perceptual Computing Lab OpenPose GitHub Open Repository, and there it provides details about the OpenPose, which is basically real-time multi-person detection system, and it is an open source library, and we can get an output like this. Even it works for a video and in real time. It can perform the pose estimation for the whole body, which includes the body, foot, face, and the hands pose estimation in 2D, as well as for the 3D reconstruction. We can use this open pose. And also it has a Unity plugin. And the interesting thing is that it doesn't matter how many people in the image are, its accuracy is still not affected. It has the same constant processing time. And the main features include for the 2D real-time multi-person key point detection, it can detect 15, 18, or 25 key points from all the body, including the foot as well. And basically it also includes 6 foot key points. And as we mentioned that it is invariant to the number of people detected, we can also use OpenPose to detect hand key points, also the face key points, and also for the 3D real-time single person key point detection. So today I'm just going to show you how can we perform the detection of 25 key points from the whole body from an image for a single person, which of course we can later extend it for multiple persons as well. As an input, we can take any of these, maybe images, videos, webcams. So you can directly read from IP cameras, or you can add your own custom input sources. But today I will start with the image. So let's start with a simple one. So as an output, we can get the points displayed or overlaid on the image, and we can save them in any of these formats, or we can get in JSON, XML format, or YML format. Today we are going to get the key points as an array, and then I will process them and will show them on an image. And as a hardware, you can see the operating systems, hardware, CUDA, OpenCL, and a non-GPU. So today I have a CPU only version, so I'm going to use the CPU version. And so remember that it will be a little bit slow, not a little bit too much slow. It will not be a real time. So the first thing that we are going to do is the installation. So there are two possibilities for installation. We can build from the source, and we can directly use the Windows portable version of OpenPose. So which I will show you how we can use. The simplest and easiest way is to use the latest Windows. But if you want to build from the source, then you need to follow these instructions, which of course I will not do today. So let's start by downloading the Windows portable version of OpenPose. So I open it, and we can go to this link, and here are some instructions. NVIDIA, since I don't have NVIDIA, if you have NVIDIA, then go ahead and update it, the latest versions, and then you can download this OpenPose. So this is what I'm going to do. I just click on releases section, and over here, as we can see, this is the latest version. If you are using GPU, then you can download this, which is also the recommended one. Since I don't have GPU in my this laptop, so I'm going to use the CPU version, and this is Python 3.7 it says. So I'm just going to click on it, and it has already started downloading. Once it is completed, then I can show you what we can do next. One more thing that we really need to understand is how we can process its output. So from the main page, I'm going to the doc, which is the documentation. And when we click on the output.readme file, so here you can see that how the output will be provided and how the points of the pose will be ordered. So this is what I'm going to do. Pose output format for body 25 means I'm going to get those 25 points. And you can see it will start with the 0, which is representing the nose, I think, and then 1, and then left side or the right side 2, 3, 4, and the right side 5, 6, 7. So this is how 25 points are ordered from 0 to 24. If you are going to use the COCO trained model, then in that case we have 18 points. So those 18 points will be ordered in this way. And for the face, we have 70 points. So right now we are not focusing on that. So I will be only discussing about the body parts, 25, and we are going to extract them. And for similarly hands, this is the format. So how these are actually formatted is really important, and for every person the pose key points will be located like this. Three things will be associated for each point. One is the X and Y location of every point plus the confidence score, that what is the confidence score of this point being the nose or not. So this is what actually formatted for all the points. So the X and Y location followed by their confidence score for the second point, X1, Y1, and the confidence score, so on and so forth for all the 25 points. And these coordinates are basically normalized between 0, 1, -1, 1, 0 to source size, or 0 to output size, etc. These depends on some of the flags that have been defined. And one more thing, we need to notice that the confidence score will always be between 0 and 1. So maybe we can apply a threshold to select the points which have more confidence score, so which we will see. Similarly for the face, you can see them, they're formatting, but since I'm going to look at the 2D pose, and this is what we will get actually. If we are going to get the pose key points for 2D, then this will be the ordering for all those points. So this is the X coordinate, this is the Y coordinate, followed by their score. So it is a pretty high score, you can see 0.8459. So similarly for the next point, the points which are basically shown here. So all these points, 0th point, the first, second, third. So those are ordered in the same way. So this will be the first point, this is the second, third, fourth, fifth, until the 25th point. So we are not going to use the part candidate enabled, so I just want to show these points, so I'm not going to discuss about them. One more thing that we need is to how we can order them, how we can get those points. So to keep that information, we will store all those points in a dictionary. So this nose is the 0th location, 1 means the neck, right shoulder, 2, so this is the ordering. So I will just copy it and format in the C#. Remember that I talked about 25 points. So these are the 25 points starting from 0th to 24, and we have one more point to represent the background. So there will be total of 78 elements in this array. Remember that, because we have 26 points, and for each point we have 3 informations related to 1 point. So we will see that I hope that we will get 78 elements in that row to get the information. And that's it. And also one more thing, I will show you that there is some relationship between the pairs. If you want to draw the skeleton, for example, then we need to know the relationship. For example, 0 and 1 are related to each other. 1 and 2 are next to each other. So we can draw a point between 1 and 2, 1 and 5. for this 25 body 25. So we also need to define a 2D array representing this relationship so that I can draw the skeleton if I want to draw them. But if I want to just draw these circles or these points, then just this information will be enough for me. But sorry, this information will be enough for me. But for drawing them, I also will create another 2D array to represent this, that which point is next. For example, 3 and a 4, we can draw the line between them. Similarly, between 2 and 3. So enough of the theory. Let us go and install this OpenCV, and I'm going to extract it somewhere here. Okay, and then I'm just going to copy this OpenPose to a location where you must have the admin right, where you can read and write them. Remember this. So I'm going to go to the F location and I'm going to paste it. You can place anywhere you want. Okay, so I can go to the OpenPause and remember that there is an instruction.txt. I'm going to open that. What this one is going to tell us is important, and double click on the models.get base models.batch to download the required body, face, and hand models. So the models are not installed, already trained models. We need to download them. And also you can download the models.get Coco or MPII. This is an optional one. So I just want the default one. What I need to go is go to the models. And if you check here, we have a pause and there are 25. This is only the architecture of the model is given, but the model trained model is not downloaded. So we need to download it. Similarly, if you want to use the Coco, you can also need to download it. Similarly, MPI is also, the model is not here, only the architecture of the models is provided. So to download that, this is what it is saying. If we double click on it and get batch based models, let's open it, edit, and then you can, so it is just connecting to this website and it is downloading the pose, face, and hand data sets, and that's it. And similarly for this, if you want to use the Coco or MPII, then you can also download them. But since I'm going to use this get base, this base 25 model, so just I'm going to use this. So you can directly double click on it and run it, but since I am not logged in as an administration into this laptop, even you can, if you want, you can open the command window from here and then you can run it. But since I'm not the admin of this one, so what I need to do, I need to follow a long way. So right click and run as an administrator, and then I need to go to this location. But for you, if you are the admin, you can just directly double click on it and it will start downloading them. CD OpenPose and CD models. And now I'm going to start this base, okay, and I'm going to run this get base models.batch. So now you can see it has started downloading all the models. So this one is right now downloading the pause iteration 5844.kfa model. So it will take some time because it will download the models for the pose, for the hand, and for the face as well. So I will stop the recording and I will continue once it is completed. Okay, so the hand and the face and the pose models have been downloaded, and let me close this one. We can confirm it by checking the pose and the body 25. Now you can see that the already trained model has been downloaded, and also we have already the architecture of the model. So we can go ahead and start loading this model and then try to detect the body pose by extracting the points. I already configured this project, which uses Emgu CV 4.5.1. You can check my previous videos how to configure it. So let me go ahead and click on this menu strip and add a new menu item. So inside this process, again into the collections, and I'm just going to add one new item, and let us give it a name, pose estimation body 25, so that I will in the future I will also work on other parts as well. So let me give it name as well, and then click on OK. And from here we can select pose estimation body 25, and in the events we can double click on this event. So when we click on that menu item, we will come to this event. So I'm just going to make sure I'm using this try catch, that I can handle the exception. The first thing that I will make sure that I read an image, and as you know from previous, we read an image and put it in this dictionary. So imgdict dot contains key. I'm just going to check that my input is there. Actually, if it is not there, it means that we didn't read an image. Then we can throw an exception. Throw new exception object, and we can write a message that please read an image first, and otherwise we can go ahead and read that image. So let me create an img variable, and we can read from imgdict, and this will be input. Let me clone it so that it will not affect the original one. Okay, so this is a BGR image. So we are storing these BGR images inside it, and we might need its height and width. So I'm going to get the height is equal to img dot, let me correct the spelling. And also we need the width. Later we will use it, and we can store it in the variable dot w. Apart from this, we also need some variables which will be used by this OpenPose. So for OpenPose, we need it. For example, what should be the input? Usually the input width of the image will be 368. So I'm just going to resize our original image into 368, so it will give me the same number of points that I expect from the OpenPose, and input height is equal to 368. So this will be the width and the height of the input tensor, and to refine the output based on the confidence, we can also define a float. We call it threshold is equal to 0.1. You can reset it to a higher value. Please put an F here to represent it as a float. And how many points that we want to extract is the 25 points we are expecting from the OpenPose. Another thing that we need is the point orders. So these all points, the ordering. So I have already created a dictionary. Instead of writing them one by one, I will also provide in the description. So I'm just going to copy this code and paste it here. So this is the dictionary of all those points of the pose that we are going to extract. For example, for the nose, it's 0, neck, these are the orders. So right shoulder, so a string followed by an integer value. It's a dictionary that I have created. So this will be enough to draw the points, just like this one. I mean, just the point, draw the points. But if you want to draw the links between the 2 points, edges, then we also need to define the relationship between, for example, 0 and a 1, 1 and a 2, 2 and a 3. So what I'm going to do is I already created another 2D array. So I will provide these 2D array and this dictionary, and I'm just going to paste it over here. This is solely for the purpose of drawing the skeleton. So we just created a 2D array of integers, and inside it we are defining that relationship, that one is connected to 0, one is with the 2, one is with the 5. All these information is there, and these are the points, and then we are going to draw them for the nose and the neck and elbow. So these two things, instead of writing them one by one here, I already created them and I copy paste these two. So once we have this information, we can load the cafe model. And let me write it here, proto text path, and we can put an at the rate here, and I will copy and paste it, and also model path. And I just need to read these paths from the location where I downloaded them. So this one will be for the proto. Okay, the architecture, I'm just going to put it here. And for the, let me close this one. And another one is the model itself. So we need to copy that path and then paste it right over here. Okay, so once we have the models path with us, we can go ahead and read the models using OpenCV. So we call it net. So I'm going to use DNN. And if you don't have the DNN over there, what we can do is we can go and call it using emgu.cv.dnn. Okay, so I imported this using statement, and then we can write dnn invoke dot read from cafe. So since I have the cafe model, as you can see, we can read the cafe model. So this one is expecting a string of proto text. So proto text, and we can provide a cafe path also. So we have the model path. So this one will load the model according to the architecture, and this is the pre-trained model. It will load the weights. So now our model is ready for using it. And through the model, we want to take this image as input, but since this one is expecting a tensor, so what we need to convert this image into a tensor or blob object. So what I will do is I will create a blob from this one. We call it blob is equal to, we can call this dnn dot blob from image. We can generate a blob from this image. The image will be img, and the scale factor, usually it is expecting the scaling to be between the values to be between 0 and 1. So I divide it or multiply it by 1 by 255 to scale them between 0 and 1. And the size that we can provide is, as I mentioned, the input width and the input height. That was 368 by 368, which I already declared above. So this one will be the size resized into this tensor. And if we want to provide, normally it applies the mean normalization, so it subtracts this mean, but I just don't want to do that. If there is a need, then you can use the default. So I'm going to do 0, 0, 0. It will subtract 0, 0, 0 from it, so it will do nothing. And this one says swap RBG. We don't need, because Cafe can directly take this BGR as directly input, so I just keep it as it is. And we don't need to set the crop or other things, just keep them as false. Okay, so rest is the default. And then what we can do once our blob is ready, then we can set the input for our network. So what will the input is this blob. Okay, and we can also optionally set the which backend we want to use. Is normally I'm just going to use this OpenCV, but if you have CUDA or others, then you can also use them as backends to make sure that I'm using this OpenCV. Now my network is also ready. It will take this blob as an input, and now I want to get the output. So we will use this net.forward method, and let me store the output into this output variable. We will use net.forward method, and this one will pass our input through the network, and it will give us the predictions back to us, the key points. This output will basically be a 1 by 78 by 46 by 46 matrix. So those 46 by 46 basically will consist of the heat maps for the points that we have. For example, this is the heat map for the candidate points of the shouldered area, for example, like this one, as these are shown over here. So out of these, we need to select the point that is the maximum with the maximum probability. That will be our final point. So what we need to do, we need to do the post processing. I need some variables, so I'm going to define, let's say h is what is the height of our size dimension that the heat map. So this is the uh, third element. Similarly, the w is output dot size and the heat dimension, size of dimension, that is the fourth element. And also processing this mate becomes easier when I convert it into an array, C# array. So let me call it heat map is equal to output. It is basically a mate object, so I will call get data. So it will be converted into an array so that I can loop through it. And I want those points, so we need to store those in a variable called point. I am going to create a new list of points, so those 25 points I am interested. And since there are 25 points, I need to loop through to find those 25 points from those heat maps. So what I will do, I will write a main loop from I is equal to n points, which I already defined to be 25 above. And then for each point, we will get this heat map for every point, and I will store it in a matrix, so it will be easier. So this is one of the way I can do. So I will create a matrix of float, and let us call it matrix is equal to new matrix, and its size will be the same as our W and H. It is a 46 by 46 heat map in this case. And then I will loop through this and copy from our heat map into this matrix and then find the maximum. So this is one of the ways that I want to do. Of course, there are many possibilities. So rows, and this row is less than height. Okay, and for the columns, let's say columns is less than our W. So I am looping through it and copy all those elements into this matrix, into the location row and column. And this will be heat map dot get value. The first ID is the image ID. So this is, of course, I have one image, and the second one is for every point what we want to extract, and the third one is the row and the column. For ith point, I want to extract those 46 points, and of course this is matrix, not mate. Let me set it to matrix, and this one wants to be a float, so I will just write the float over here. Okay, so once we read those maps for every point into this matrix, then I want to find out the maximum value. So that will be one point representing that body part. I would like to apply this minimax log function. And to apply this, I need some variables defined. So let's say min val. Let me initialize it to 0, and the max val is equal to, it's also 0, let's say. And also we need 2 points, that min log is equal to, let's say, default value, and also max log also set to default value. And now I can apply CV invoke dot min max location. So this one will find the minimum and the maximum location of the values from my matrix, that is the heat maps for each point. And we need to pass by reference the min val. So this, remember that this should be a value, reference by max val. So this one will give us the value and also the locations. So reference by min location and reference by max location. Okay, so I'm not interested in the min, but I'm interested in the maximum location and also its maximum value. What we can do is, first of all, to display the image, we need to scale the x and y coordinates to fit the original size of the image, because we already reduced the size of the image to fit into the tensor. So what I will do is, first I will scale my x and y according to my image dot width, multiply by the max location dot x component divided by our w. Similarly, we do the same scaling for the y coordinate, img dot height, multiply by max location dot y component, or the y coordinate, divided by h. So this one will just rescale so that we can fit the point on the original image. And another thing that I want to select the points which meets the minimum threshold which I have defined to refine those outputs. So if the max val that we have is greater than the threshold that we have defined, then we can add it into the points. So points dot add, and we need to create a new point here with the x and the y values, and that's it. In else case, we anyhow we need 25 points. So again, I will add, and this time I'm going to add a new point dot empty, an empty point, because we must have 25 points. Okay, this way we were able to obtain the points. And once we have the points, then we can go ahead and draw those points on the picture and see if we can get the results or not. So this is, I'm going to display those points, display those key points on image. So for integer I is equal to 0, I is less than points dot count, and then let me read this one into a variable called p points, the current point, ith point, I read it into this p variable, and we need to make sure that it is not empty. If it is not equal to point dot empty, if it is not empty, then we can go ahead and draw a circle on that, around that. CV invoke dot circle image, and the point will be here. Radius, let's say it is 5, and the color, whatever color you want to choose. Let me say I want to draw a green circle, and I want to fill it, so I provide -1. And also, in order to display the ID of this one, so we can also use this put text. The first parameter is the image, the second parameter is i.toString, and the point where we want to display is the p, and the font face dot simplex I will be using. The scale, just I want to scale a little bit down, and the color that I want to display is BG will be 0, and R will be 255, it means in red color 1. And if we want, we can provide a line type also, anti-edge. So this one will display the text also, and then we can go and display this image in the picture box is equal to img.to bitmap. Let me run this app and then click on pose estimation. It took some time, but it displayed the points, as you can see. So that is what actually we wanted. So it has displayed almost all the points, I believe. This 0, 1, 2, 3, 4, as you can see the numbering. So that looks awesome. So I just want to also connect these 2 points and want to draw the skeleton. So to draw the skeleton, as I mentioned, this one point pairs will be used. So we need to draw between 1 and 0, 1 and 2, 1 and 5, and so on and so forth. This is fixed. So I will use this one to draw the skeleton. So I'm writing here, draw skeleton. We again need to loop through all those skeleton points. So for integer I, and we have point pairs dot get long length, so it will give us the dimensions, how many elements we have along the first dimension. And we need to tell that from where to start and where to end. So like, for example, from this will be the start and this one will be the end point. So we can do that like in variable start index is equal to point pairs, and we can select the ith, and the first one will be the start point, and variable end index, so will be from the point pairs. Again, this I will, for the ith one, the second one will be the end index, so between first and the second point. Okay, so we need to make sure that these points exist or not. So I'm going to write a check here. If points dot contains points start index, because sometimes it might miss, you know, it might not detect all of them, and also points dot contains points of end index. If those points exist in our detected points, then let's go and draw a line between them. CV invoke dot straightaway line. So for this line, we are expecting the image that we want to draw on it and the 2 points on which we want to draw. So points will be the point, the start index, to the point in the end index. And then we can give a color, for example, we can give a color in a different, maybe a green color, BGR, and the thickness, let's say 2, and the rest will be a default one. And again, now we already showed the image, and let us run the application once again and see the result. I'm going to open the image again, and let us run this one, pose estimation. So you can see here, that is an awesome. So the skeleton has been drawn for this image, and that is the open pose for you. But remember that since I'm using CPU, it is not real time. It took almost 6 to 7 seconds to process for this one image and then give me the results. So according to the paper, it is a real time, but you need the resources, the GPU, and also the information is provided that how it will give us the fast speed. But for the CPU, of course, you can understand that it will take some time. The basic idea was how to use the OpenCV with EmguCV CV and how we can detect those points. And in next videos, we will see how we can apply this one on videos, and then how we can also detect the pose for multiple people in image. So hope to see you in another video.